Are these compounds ionic or covalent? And if they're ionic, we are going to write out the charges for the cation and anion that are present there. Now, determining a difference between the ionic or covalent compound can be done just by finding atoms on your periodic table. An ionic compound is most often in Gen Chem a compound between a metal and a nonmetal. So even if you have one metal present and one nonmetal, we can safely say this is an ionic interaction. A covalent compound, everybody is a nonmetal. So when we look at our periodic table and look at this first one, dihydrogen sulfide, H2S, which is very similar to H2O, everybody is a nonmetal, so this is a covalent compound. We can predict, because it is both nonmetals, we are predicting that the interaction between the atoms are covalent. Cobalt nitrate. Now, we have nitrate here in parentheses, NO3. We have nonmetals, and we have a metal. Bingo. We're going to say this is an ionic compound. Oh, excuse me for a second. This is a little model meant to show H2S. Noticing it's a bent configuration, the sulfur in the middle, and the two hydrogens kind of poking out like that. Looks a lot like a model of water, H2O. Just its geometry, it's flat, right there. This ionic compound, cobalt nitrate, here we have a cobalt atom, and here are the two NO3s. And they're going to position themselves something like that. Now, the charges that we're going to have on these right here. Nitrate is a commonly known anion with a -1 charge. You should make sure with your instructor if you have to know or memorize nitrate NO3. Now, cobalt is a transition metal, and it can have multiple charges common to it. So to whether predict this is a +1, +2, or +3, we don't have to predict. We can just do the math here. If this ionic compound has arranged itself to have a neutral charge overall, then this cobalt in the center must be a +2 charge. So the cobalt is a +2, which is equal or opposite to the -2 that the nitrates contribute, so they neutral each other out there. And this is a little model trying to show the nitrate geometry with a little double bond in there, and the cobalt kind of nestled in between them. This final one, magnesium chloride, try to find them on your periodic table, magnesium and chlorine. Great job, they're ionic. We have a metal and a nonmetal. They're so far away on the periodic table, we can predict their interaction is going to be an ionic type of interaction there. And this is meant to be the magnesium in the center here. And this is the two chlorine atoms. We're just going to put them opposite of each other right there. Now, the charges for magnesium and chlorine, we can strongly predict. We can predict confidently based on their location on the periodic table. Magnesium, please find it on your periodic table and note that it is in the second column. Let me get my other periodic table out. This is the box, beryllium, magnesium. This is the box that magnesium lives in on the periodic table. Note its location and note that if it lost 2 electrons, it would carry a +2 charge. Quick fun fact, if anything loses 2 electrons, it would be a +2 charge. Things in this column, lithium, no, it's not lithium. That is beryllium. This is calcium. This is, I'm not sure what this is right here. But things in this column, they carry a +2 common charge. Chlorine is over here in this box, in this column, excuse me. And Chlorine, because of its electron arrangement, if it can grab one more electron, it would have a -1 charge. So chlorine does that. It often grabs, steals, begs, and borrows a -1, an electron to acquire a -1 charge. And as in this column, fluorine, chlorine, bromine, iodine, these guys, they often carry a +1 common charge. Thank you.